Now let's welcome Mark Walters to the stage, a distinguished teacher here at Ryde TAFE. Mark has spent 23 years teaching certifications in conservation and ecosystem management, and has also made a mark in the private sector as an ecologist and a bush regeneration officer. Today, he'll discuss the significant yet often overlooked potential of topsoil from development sites in restoration efforts. Please welcome Mark.
Thank you. Hello, guys. So pretty much almost 5 months ago, I was asked, would you like to come and have a tiny little chat with a group of bush generators? And this is it. So it's fantastic to see so many people around and also so many familiar faces. Just as a disclaimer before I start, it wasn't just me about the soil translocation, the one who makes the most noise. It was actually a whole bunch of council people who really pushed forward. So people like Jenny Powell, Steve Atkins, they really, at the same time, there were some people from national parks also got involved. So a lot of the stuff was a joint thing between Warringah Council, which is now defunct, and also national parks. And it's following on from what Peter said. I think the biggest sort of issue is that I think this process is fantastic, but it needs the governance, it needs the recognition. So essentially, this presentation I'm going to do is about 25 years of my experience with it. So when the term specialist is used, I kind of get a bit of juice for the hour. And so basically my background is that I've pretty much used to work in the construction industry. I was a crane driver and a rigger. And while I was doing that, I was doing a sideline of being an outdoor guide, and then pretty much left that when we had the recession we had to have, and then ended up working as pretty much a bush generator, and then went to uni and did environmental science. So I've kind of have this weird kind of mix of construction skills, but also bush generating skills. And then worked as a bush generator for 6 years, came to TAFE, have been here ever since. And one day I'll get out, okay? So pretty much the photos you see on the top are a site that's basically been rehabilitated. And it'll form the second case study we'll have a look at. But it's quite good because you can actually see how the site started and in a sense what the site looked at about 2 years later. So I'll start clicking through. Okay, so I'll start with these questions. How do you revegetate this kind of degraded environment? So this was what we were faced at when we were at Warringah Council. This is actually owned by National Park, and we were looking for a suitable site to translocate to. And we ended up basically translocating to the site and remediating it. But I mean, how do you actually fix a site like that? And the second thing is, once you've done the fixing, how do you measure restoration success? Which I think is a big question. And I think it's an industry-wide question where people really should be focusing on actually how do you measure your success? Because if you don't, you'll ending up in a dead end, or you'll just be wasting resources, which, according to Frank, are very limited, on sites that should really be focusing on other things. So this site is pretty much stuffed as biotically and abiotically. And Okay, so thinking about restoration success, if you look at the CERA guidelines, Principle 4 basically states full recovery is what you're aiming for. And I think that's a noble effort for most sites because of the surrounding factors. But I think in the case with topsoil translocation, if you've got the right site, you're actually going to do quite well with this one. And it talks about full recovery. So these translocation projects have become self-replicating. The fact that 2 of them have actually now gone through a fire, one 8 years ago and one 4, and they've regenerated, which I think ultimately is the test of any kind of restoration success. You know, will it stand up by itself? And if you start looking at the CERA attributes, so if you haven't come across the CERA wheel, I suggest you do. It's a really good way of actually looking at a site holistically to figure out where your opportunities are and where your limitations are. 4 of the 6 ones are on the board, okay? And you can download the CERA wheel from the CERA website, okay? And one is the physical conditions. So if you're looking at the physical conditions of chemical and physical substrate, basically your soils, if it looks similar to the actual reference community, you're doing well and you've actually succeeded. In this case, you're actually stealing that soil from a site and moving it to another place. Okay, so the physical structure of the soil gets smashed, but ultimately the texture, the chemical properties, the nutrient stats is pretty much spot on. Also, other one is species composition. All the sites that I've been involved with have had high levels of basically species diversity because we've taken the soil from a different site with the seed bank within it. And the other one is structural diversity. So most of the sites that I've been involved with, except for one that probably Paul will ask me about later, has issues to do, it doesn't have issues with structural. You've got your canopy, you've got your mid, and you've got your ground. And the big thing we're focusing on, or you'd focus on, is actually getting the soil with your ground layer, okay, and shrub layer. Canopy often can either be planted later or can self-recruit from outside, particularly if you're planting or revegetating or actually translocating to a kind of a disturbed area within a greater, healthier remnant. The other one is basically looking at your structural diversity. So you're looking at all your age classes and your structural layers. Now, because you're translocating, you're not going to have all those structural layers, but give it time, it'll sort itself out. And sometimes people look at it and go, there are no trees. The trees are there, but they take far longer to appear, actually establish, but they will eventually. And then ecosystem function, which is really, I think, the acid test for any kind of community. Will that community become a self-replicating, sustaining, kind of resilient community, and also resisting external threats? Okay, so what is topsoil translocation? So if you haven't heard me talk about it before, okay, which most of you probably have, or many of you have, it's basically where you're moving seed-rich topsoil from one site to another, okay? And usually what happens is that you prepare a donor site and you prepare a recipient site, and all the ones I've been involved with have been due to developer consent being given to clear land. So rather than that seed bank being sort of either composted to kill it for later landscaping soil on the site itself, or taken to the tip as contaminated waste because it's too high in organic matter to be used structurally for building, that soil itself can be relocated somewhere else. Okay, so the impetus of most of that was because there were endangered communities that have actually forced that thing to be done as a kind of remediation effect after consent was given. So it's more likely to be a consent condition from council rather than from state government. And I think particularly the sandstone kind of areas, or areas with high in the sort of kind of Proteaceae, Fabaceae kind of species, about 89% of our species in those kind of environments have some kind of seed bank that's stored within the soil, either ephemerally, maybe 16%, or persistently like your acacias and your Fabaceae. And most of that soil is in the top 5 centimetres. Or most of that seed bank is in the top 5 centimetres. So if you can actually strip off that layer of seed-rich soil and relocate it somewhere else, you've got an instant kind of starter kit for a whole revegetation process. So we're going to have a look at that. It's well done in WA. It's been done in Europe, but very rarely have I heard of any other projects being done in New South Wales, which I think is a governance issue. And I think it comes back to what Peter was talking about, the fact that at the industry level, we kind of get what's going on, but at a kind of governmental level, way above us, we don't get that kind of connection between it. Okay, so how's it done? Pretty much the first thing is you identify a donor site, and that's usually done through the DA process, and it's identified. And then from that, you prepare it. So there may be initial weed clearing, moving particular species that may be problematic later, identify the area to translocate to, okay, or from, and then you start stripping the site down. And first thing you remove is the trees, and then you start maybe brush cutting or slashing the ground layer. And you can either rake up the leaf litter, but you'll see later, raking up the leaf litter is not super important, okay? But you try dismantle the site into its parts. And you can see there the topsoil stripping is occurring after the shrub layer and the canopy has been removed. So that's an excavator taking off 100 millimetres of topsoil. And we do 100 mil, well, I've always done 100 mil for two reasons. One, you're ensuring you capture the entire seed bank. Second thing is you're basically making sure that any rhizomes that come along as well, or rootstock, are also included, because you don't want to just take off that 50 mil, because you're probably shearing rhizomes in half. So you want to try and get as many as you can. And later on, that's important on the recipient side. If any rhizomes make their way to the recipient side, it's good to have a busher generator just uprighting them and standing them up and replanting them. Okay, so then you get your rhizomes coming through. The other thing too, it's good to have a bushy generator supervising the machinery who can actually identify at what layer to scrape. Because sometimes you find deeper pockets of more sort of seed-rich soil, and other times it becomes quite skeletal and very little kind of seed-rich topsoil. Okay, so I better start moving on. Okay, so there's a recipient site. This one we had to end up basically weed controlling it. Heaps of pampas, heaps of acacias, we got rid of them. It's very irritating. Then once the site's ready to receive it, you kind of reverse build the site. So essentially on the donor site, you strip off the leaf litter, stockpile all the brush matting and the vegetation. Then you take off the topsoil. And then if you need subsoil, you get that first. And that goes to the recipient site first. And then you start relayering it out into layers and reconstructing it layer by layer. So, yep, that's 18 months later. Okay, so quite profound. So if you've gone from that bitumen kind of wasteland to this bigger, diverse kind of regenerating community, but obviously no structure there, or no big structure. And eventually, yeah, you can see the seed-rich topsoil there, basically, which is where hopefully all the good stuff, all your sort of biotic material, all your microorganisms, and your fungi and bacteria are coming from, but also your seed bank as well. So yeah, that's pretty much the general process. That's pretty much 2008. So that's basically 8 years after the translocation. So you can see the power lines in the middle. They'll kind of be useful later. But you can see it's quite diverse. There's a bit of structural complexity arriving, and that's 8 years after the translocation. But now you can also see some ukes recruiting too. And that's 24 years. Same spot. Now what's happening there, that's 8 years after the burn. So this is regeneration post, basically burn. So you had the translocation process, 16 years of regeneration, a burn, 8 years basically of regeneration post the burn itself. So I think that in a sense passes the acid test of restoration I was talking about. Okay, so I'm going to look at 3 case studies. Okay, the first one in 1989, JJ Hills, was just a trial to see if it worked. We really wanted to see if this process worked. We've been reading literature at council about this process, and we all decided to have a go. And also people like Tony Auld from National Parks got involved as well. So it was a collaborative kind of thing between council and National Parks. And the big worry was we were worried about this being a way of actually allowing development to occur with the excuse that, just move the soil of the season up. And we didn't really want that to happen. Okay, so the other 2 sites we'll have a look at in a bit more detail. They're the translocation sites. So the donor is the green patch, and that's Auslink or Bunnings. And then if you look around, you can see the yellow stars are pretty much the ones I'm going to be talking about. And then there's 2 other local kind of sites which were translocated to as well, which I was either directly or partially involved with. But I'm going to focus on the yellow ones. So the case study pretty much was really up at fire control in JJ Hills, and we created a 5-metre wide strip about 240 metres long and ended up putting 24 plots in. And each plot was going to be treated slightly differently. There's a multifactorial treatment. So some of it we're looking at germination responses, okay, so either nothing, smoke product or burning, and then the other ones are leaf litter. And the idea was to see if we could put leaf litter either back on top or just excavate and dig it up with the topsoil and see if there's any effect. Okay. And then the subsoil. Do you need a subsoil or not? And that's pretty much me just saying exactly the same thing again. So as part of this little study, I ended up looking at the translocation treatments over a series of time. So 5 months, 19 months, 40 months, and 16 months or 5 years, and kept data the whole way through so I could plot progressive change. And so basically I was looking at everything below 2 meters and essentially looking at stem density and also treatment type. That's it at 5 years. So it's fairly dense. So nothing in there was planted except for one council officer decided to plant bladey grass on the edge, which I think in translocation processes if you're going to do translocation, be really on top of your grassy management issues, because the grasses just tend to go absolutely off, particularly things like couch. If you've got couch on the donor side, I'd just not even go near it. I recently saw a translocation in Western Sydney where they didn't get on top of their grass control, either on the donor site or the recipient. I'm not quite sure which one. And it's essentially failed. So it's sad, because it would have been quite a good outcome. Okay, so that's just sampling the structure using quadrat and a levy pole to figure out vertical structure, horizontal kind of species diversity and density within that within a plot. Here are the results. Okay, looking at leaf litter. So the leaf litter itself was either mixed into the topsoil as it was removed, or was absolutely separately stripped and removed, and then later reintroduced on top. And you can see that the average is about 10 to 12 species per square metre. Okay, so it's pretty diverse. So if you're thinking from a planting point of view, I see you guys who work in regen would not get that kind of diversity just from a planting. And then if you're looking at stem density, okay, you're up to 40 plus species by a year and a half. And it declined over time, but that's just natural attrition. And there was nothing really different between the two treatments. So effectively, you can just dig up in training the leaf litter into the soil and relocate it. The second experiment was pretty much looking at, well, this is the results for that one, for subsoil. So if you're looking at subsoil, again, the results show there's no difference in subsoil. Didn't really matter. But that's interesting considering the third site we look at, where subsoil is a bit of a factor which is affecting the canopy development. Here's the germination treatments. So red is fire, and then pretty much disturbance is the blue. So the disturbance was just the process of disturbing the soil and digging it up and just leaving it to germinate by itself. And then the black one was smoke product. And you can see pretty much by about 40 months, everything's converging. But what was interesting with the fire was you can see that massive flush of germination in the top left. It really massive stimulation to the seed bank due to the fire itself. And then over time, everything converged. But what was interesting about that flash of germination was that it had a structural layers, looked a little bit unusual. So this one, pretty much leaf litter accumulation on the site really matched. At 5 years post-translocation, the leaf litter accumulation on the site actually matched a 2-year-old reference site. So the translocation sites are much slower at building up like ground litter on the ground, which I think is important to consider if you're going to do it. You add a lot of that material to basically become substitute habitat or micro kind of climate for seedling germination or fauna later. And there on the right-hand side, with the red line, is that concavity when you walk through the sites that have been burnt as part of the treatment. The age class pretty much came up and it was hollow underneath. So you could literally walk through it and the vegetation would be hitting you in the face, but nothing was hitting you around the chest because of that very dense age class. My worry about that process was that I was actually opening up the understory for weed invasion later. I personally think that leave it alone, let regeneration occur by itself is the best way to go, because you get a full structural layer of diversity of different agents within the community, and also hopefully it'll block out weeds and control light, and also be a better kind of fauna-friendly environment. So that's some of the results. So one of the highest plots, which was a seedling, which was the burn plot, had up to 70 seedlings per square metre. So, and some outcomes. This case study 2, Monaville. So you've seen some of these pictures before. Essentially, it was done in 2000. It was done over 5 days, the whole translocation process, from the site being stripped, the donor site, to us walking off the recipient site. And so 2,000 tonnes of topsoil went in there. And the developer paid for it, which actually was happy because it saved him money. So that's 2 years old, quite diverse. You can see all the logs and stuff we've left behind, okay? And that's hopefully to create microclimates for either fauna, but also for plants to germinate. It was quite interesting. It actually did create differential germination of different species depending on what was protecting it. Yep. Here are a series of 3 kind of panoramic photos from 2000 onwards. So that's when we left the site. Note the little red stars. And that's 8 years after translocation. And that's a week ago. Yeah. So no planting, and that's post 1 fire. So I think it's doing very well. It's getting to the point where I think it could survive another fire, maybe another 4 or 5 years. But I think actually if you maximise the time between burns, that's the best. Okay, here's some plants. Yep, all came in the back of a truck. Here's some species that really, ones of note that really just don't basically, you can't really propagate these. You might do it by a bit of stem cutting and a bit of, but this is ultimately the diversity we're getting. So I had up to different 6 species. Site. Okay. This is the third one. So this is the one that's a little bit strange. What happened there was it was developer funded again, but the contract wasn't locked in. And it was kind of open-end contract, and the developer claimed bankruptcy and wanted to stop halfway through. So it was a rush job to finish it. So only half the site actually got the subsoil we required. And the other half of the site ended up on an engineeringly compacted subsoil. And council insisted on the subsoil being compacted to the point where I reckon you could land a commercial airliner on it. So it's effectively concrete. And so it was quite interesting in a sense. It was an experiment I didn't really anticipate. But what's happened there is you've got this water table which is now pushed to the surface, which starts self-pruning the bigger canopy trees, or limits their germination and growth. So I limited survey. I went and checked it out, just a quick species list. I got 60 species on site a couple of weeks ago. And here you can see the Guianeas, which were on the donor site, but because of the environmental conditions on this site and the lack of a nice subsoil for drainage, preferentially sort of selected towards Guianeas at the bottom end of the site. And that's pretty much looking at the 2 kind of experimental sites, case study 1 and 2, 2 and 3. And also if you look at the yellow kind of rectangles, that's the experimental plot that I'm going to talk about in a moment. And you can see after 6 years, you can see that the cover of plant germination is a little bit different. So it's a nice picture. And thank you, Google. So essentially with the topsoil, we're looking at 50 mil versus 100 mil. Took out all the rhizomes out of the topsoil and spread half of the plots at 50, half at 100. Essentially, you can see there's not much difference in mean cover. So it really didn't matter. So you can actually spread topsoil thinner, but you're not going to get the rhizomes you would. Species diversity, slightly better on 100. Okay. So does the ground cover type affect? The results of this one pretty much, we had a cover treatment going as well. So the 4 cover treatments were just bare soil. Can you just translocate a seed-rich soil and have nothing on the top? The other one was basically a leaf litter, okay, spread on top. Then brush matting of anything that had seeds on top as well, but also brush matting for physical control of light and microclimate. And then mulch. Some of the site on site was mulched and actually used. And if you look at the mulched one on the left, but on the sort of right side of that left diagram, it's got the lowest response. So a lot of you guys know I have a personal intense dislike for mulch. That proves it. Okay. The mulch inhibited germination, and basically the best thing we could have done was actually have a brush matting or a leaf litter on top. And I think the leaf litter can contribute extra species that are trapped as seeds with that leaf litter. Okay. So don't use mulch. Conclusion, pretty much I've just spoken about that. Mulch suppresses germination. I should have made it bigger. The other thing too is just managing a translocation. Don't forget about other things that a translocation can deliver, and that includes things like logs, debris that you can drag along from one site to another. One of my former students has an idea that he wants to create a habitat bank of logs and debris that can be moved around, say, a council area. for revegetation purposes. And I think that's a fantastic idea. Okay. But yeah, try and bring those too. Don't just think of the seed bank, bring all the other material too. The other thing too is edges always have issues. Okay. In this case, you always got to be on top of your edge issues. And one of the sites here was backed onto a road reserve full of cooler grass and other stuff, and it was never fully controlled. And the issue is the cooler slowly creeping into the translocation plots. And it's been minimal kind of weed control done on these sites in the long term. So yeah. Other things to think about, subsoil not loose enough. That's going back to that kind of engineering compaction that was done on that third site, the concrete-like site, which perched the water table up. So think of trying to get a looser subsoil for drainage, okay? Otherwise you end up, and it kind of shifted towards a wet heath environment, which is a bit interesting. Yeah. Other issues too is not using people who know what they're doing. So one former student had a little bit of soil that they wanted to get from our council reserve that was being cleared. And she asked the builder who was doing the landscaping works, can I have the topsoil? And he delivered subsoil. And really said, you don't want that stuff on top. It's useless. And the other thing too is stockpiling soil. If you stockpile soil, you'll compost it. So about 5-6 years ago, I was involved in a project where the developer got legal advice to kind of clear the site before applying for a construction certificate, cleared the site, notified council 2-3 weeks later, went and had a look at the piles. They're 5 metres high, and it was basically about 300 cubic metres of topsoil, and it was actively composting. And I stood on top of it in winter at about 8 o'clock in the morning, and my feet were sweating, and I put a thermal probe into the top of the pile, and it was at 50 degrees. So that's pretty much every bit of organic matter was decomposing and killing the seed bank. And essentially it was a great waste. And that comes back to the governance thing to do with controlling the process. Okay. In this case, council, there was a logical gap that the council only required a construction certificate after clearance. It should have been done before, so the process could have been supervised. Yeah. For me, I don't understand why this is not part of the biodiversity offset scheme. I just don't get it. Yeah, again, governance. Okay, and essentially, yeah, I think you have much better outcomes if you can actually revegetate a site using features from another site. And remember, if it's not used, it'll be wasted and lost. And there's some references, and that's pretty much it. Any questions? Todd?
Yes. You mentioned in that month that the translocations that you took part in were Duffy's Forest.
Yeah.
Are there any other veg communities in particular that you think it might excel in, or some which it wouldn't be?
Okay. I've seen it work on Estuarine Swamp Forest Oak Complex up in the Central Coast. And that was an interesting project. Partly it did have some Phytophthora on the site. But when we translocated it to another site, we had a recipient site where we had to excavate down to get the hydrology right. And the material that came through did really well. And what was interesting, the melaleucas and melaleuca stumps that came through, initially I thought they were just going to be like added habitat value kind of material, started rerouting and reshooting. And it was really quite interesting. So if I'd ever do it again, I'd actively bury those logs in the topsoil and think of long stem planting on a massive scale. Yep.
I just had a question about the governance issues again, and how you lined up and communicated with these developers or people who are getting rid of the topsoil in certain locations. So my question is on like both the personal and maybe like a bush regen organisation level, what's the best way to start doing more of this practice?
Yeah, I think it has to come from above. I think a lot of that stuff has to actually come from above and say you have to do it. One of the sites, the second one, the developer afterwards said, "You've just saved me more money than I'm going to make through the development," because it was going to cost them. It was going to cost them something like $500,000 in actually tipping fees to get rid of the material.
They tell that to you, mates.
Well, he actually said to me when we finished, he said, "Can we do it again?" Okay. Yep.
Yep.
Have you guys done any pre-studies on any fungi and post?
No. It's an interesting question. Yeah. You assume that all the spores and other sort of microorganisms coming across, that also includes stuff within the leaf litter. You're kind of inoculating the new site, but you're inoculating on a massive scale. It'll be interesting to actually see what does happen. I think it'll be very interesting. My only kind of weird kind of thoughts are that if you're digging up the soil, you're basically destroying the structure of the soil. You're not destroying the soil texture or the chemical properties of the soil, but you're breaking up the PEDs of the soil, which it'll be interesting to see if you could actually move the soil en masse. It'll be interesting to see. But I think it'll be interesting to see what's happening here. I think by the fact that you've got things like Ericaceae on the site, which are kind of really do like having kind of special relationships with soil, I think it kind of indicates it's probably coming through. Yep. Cool.
We'll have to stop questions there because it is morning tea. We've cut in a little bit, and you can ask further questions during the panel discussion or even during morning tea. At the Arbor store, we have paper there so you can write down your questions. Thank you.